See, chlorine is one of the important components of group 17. Let us understand how to make the preparation as well as what are the reactions present in it. So, preparation wise, if you notice, mainly in lab it is done by oxidation of HCl. Okay. Now this oxidation can be done by MnO2, Pb3O4, PbO2, got it, CaOCl2 or O3. These are typically the reagents which are used, oxidizing agents which are used, which will oxidize HCl to Cl2. Let me show you as the reactions. MnO2 plus HCl will convert this into, you know, MnCl2 plus H2O plus Cl2. Okay. Similarly, if you have NaCl, right, plus concentrated H2SO4, this is like a source for HCl. This is a source for HCl just to keep it, because HCl is more uh, volatile. Keeping it in a liquid state is difficult. So what we can do, we can create that instantly when it is needed and then treat with MnO2 and making this as Na2SO4, got it? And Cl2 will come out, MnCl2 will form and H2O is observed, right? Now, uh, similar reactions can be done for Br2 and I2 also, okay? Next, if you notice PbO2 also, PbO2 plus HCl will convert into PbCl2, a white color PPT plus Cl2 plus H2. This is how it will be. Okay. Next, if you have CaOCl2 plus HCl, that is also converting into CaCl2 plus H2O plus Cl2. Okay. HCl plus O3 also, to react, it will become O2 plus Cl2 plus H2. And KMnO4, we already know that, plus HCl will convert this into Mn2 plus, in this case, MnCl2 plus Cl2 plus KCl and H2O. These are by far the methods, typical laboratory methods by which we can generate Cl2. Now, industrial methods, if you notice, industrial methods, you would observe more of first Deacon's process, where we take HCl, react with O2, and in the presence of CuCl2 and heat. Okay, so that will make it Cl2 and H2O is formed. So O2 is going to oxidize HCl to convert that into Cl2. Okay. Second, electrolysis of bran solution. Electrolysis of bran solution. Okay. In bran solution, we take NaCl of around 10% by weight, got it, from seawater, right? And then we electrolyze it. This is brine. At anode, you will see, H2O will take up electrons to get into formation of H2 plus 2 OH minus, while, sorry, this is at cathode. While at anode, you will notice 2 Cl minus converting into Cl2 plus 2 electrons. That's how we can get chlorine, by using electrolysis. Okay. Next, if you want to get ultra pure, pure Cl2, then we can use simply gold chlorides and heat it strongly. Gold will get deposited. Cl2 gas will come. No impurities here. Okay. Same is the case with platinum. PtCl4 on heating. Platinum will deposit and I'll get 2 moles of Cl2. These are simple ways of getting Cl2. Okay. Now, typical properties wise, if you notice, chlorine, you know, Cl2 is greenish, okay, greenish yellow gas, greenish yellow gas. Okay. It forms hydrates, it forms hydrate as you cool it and becomes Cl2.8H2. It is a strong oxidizing as well as bleaching agent. Can be used as both. Okay. And the bleach is permanent. Bleach due to chlorine is permanent. Got it? Next, if you note down the reactions here, where all chlorine can undergo reactions, we'll see. Okay. First is about addition reactions. What are various addition reactions it will go through? Okay. So you can see SO2 gas, if you treat with Cl2 gas, it will become SO2Cl2, sulfuryl chloride. Okay. Here we require charcoal to catalyze this. Next, NO2 gas, when you treat with Cl2, it will become 2NO2Cl. Similarly, if you have 2NO gas, react with Cl2 gas, it will become 2NOCl, 2 moles of NOCl. Okay, sorry, NO2Cl. Okay, no, NOCl, NO. Next, carbon monoxide plus Cl2 will give you COCl2 phosgene gas. Very poisonous gas. So phosgene gas. These are typical addition reactions. Okay. Apart of it, how does it act like an oxidizing agent? Let us see. Okay? Or whatever the compound that has been formed, we can also see that uh, it will either be oxidizing agent or a reducing agent, right? Depending upon the situation. Okay. General reactions here. You notice general reactions. First one, if I take H2S and treat with Cl2, definitely Cl2 we expect it to act like oxidizing agent. So this will convert into HCl and make sure that sulfur get, colloidal sulfur form. Next, if you have SO2 gas plus Cl2 gas, which we just learned that it can become SO2Cl2. If that is being hydrolyzed, we will get this as H2SO4 plus HCl. So here also it is acting like an oxidizing agent, oxidizing sulfur into H2SO4. Okay. Next reaction, if you notice, it is Na2S2O3 thiosulfate when you treat with Cl2 and H2O. Thiosulfate when you read with Cl2, it will become Na2SO4 plus HCl. Okay, Na2SO4 plus HCl. Got it? But here is a catch. But it depends upon how much amount of chlorine we have. Got it? If you have a small percentage of chlorine, this is considering large percentage of chlorine. Okay, large percentage of chlorine. If you have Na2S2O3 plus Cl2 plus H2O, then it would probably give this as NaHSO3, sorry, SO4 and HCl. Here, this is used as a anti-chlor. So that means when you have a small percentage of chlorine, you can remove that. And in that case, it will become NaHSO4. Okay, depending upon the reaction, accordingly you make it. Okay. I2 plus, Cl2 with H2O. If already I have an I2, then it will become HiO3 plus HCl. Got it? And in fact, I2 will make a similar reaction even with HNO3, O3, etc. Now, what if I have a I minus instead of I2? I minus plus Cl2 plus H2O will give us I2 plus HCl. I2 plus HCl. Okay. So here it will become more easier. Now, if you add excess amount of chlorine, that will eventually push this to formation of HiO3. Okay. Next, if you have H2O plus Cl2 in the presence of H nu, this will also become HCl plus O2. It will become HCl plus O2. These are a few simple reactions of chlorine, guys, which you need to know from exam point of view. You will not be asked anything more than that, but I hope you got an idea about how to think about these kind of reactions. Yeah. Now, when it comes to iodine, right? Bromine and iodine, okay? Few reactions which you need to know. It is when it comes to preparation of iodine and bromine, not much preparation wise it is asked. Only one or two reactions are there that we will see now. See, if it is about bromine case, right? Preparation wise, we take traces of brine. Okay. Sir, here also will form HiO4. No, beta, Satvik, the other day also I told you. You don't get HiO4 directly. Okay. Here also it will form HiO3. Next, check. Traces of Br minus from brine, that is sufficient enough to oxidize itself into Br2. Okay. Now, what we do, whatever the Br2 that we have generated, right, it is collected, Br2 collected in air as the traces of Br2 got oxidized, okay, and air and and passed through Na2CO3, okay, Na2CO3. Now, what would happen is when you get Br2 out, right? See, this is what we will see. I'll write the reaction wise. See, Br minus, which is present in sea water. I have Cl2 which has been formed, and that will convert this into Br2 plus 2Cl minus. And this Br2 we are adding to Na2CO3, which is basic in solution. In basic medium, bromine will undergo disproportionation. So it will become NaBr plus NaBrO3. Got it? NaBr and NaBrO3. Now, what happens once you get this form? These are all soluble forms. And most of the forms which are soluble, we take that solution, okay, take that solution and add NaBr and NaCl, NaBrO3, whichever it is present. We add it with H2SO4, okay, dilute H2SO4. On adding with dilute H2SO4, now what would happen? it will undergo calm proportionation reaction. Now, if you see Br minus and BrO3 minus, will undergo calm proportionation reaction to give Br2 liquid, here Br2 liquid, and rest would be all other ions like SO4 2 minus and so. This can be distinctly separated out because it will not have that high level of solubility, correct? And using distillation, Br2 will be separated out. Got it? That's how usually we prepare the bromine form. Now, if you notice, iodine form, how we prepare. Again, most of the salt, what do you say, chili saltpeter, chili saltpeter, okay, which is NaNO3, will come with an impurity, which will always come with an impurity of NaIO3. This is the impurity which you will notice, okay, and this impurity is sufficient enough to make, reactions. Clear? So what we do, NaIO3 or KIO3 is separated by distillation, by distillation of NaNO3 mixture. So once you get KIO3 here, okay, we'll divide that into two parts. First, what we do, we react NaHSO3, correct, with IO3 minus. React that with IO3 minus, by which IO3 minus will oxidize that NaHSO3 to NaHSO4. So we'll get I minus. This is first part. This is the first part which we do. Okay. Now this first part is again mixed with IO3 minus, which was already present, and adding it to dilute, and then adding some dilute acid to it. Same logic. The minute you add it to dilute acid, you'll get I2 plus SO4 2 minus plus H2. So that's how it is added to the first solution which was present. Okay. This I2 solid is purified by sublimation. By sublimation, we can remove the vapors of iodine and get this. Yeah. This is about iodine preparation. Next. If we have to prepare fluorine, fluorine is very difficult in terms of preparation. In laboratory, where we go through a very rare case of reactions here. So one of the reactions we'll do is K2MnF6. When you treat this with SbF5, okay. Now that would give us 2 moles of KSbF6, a complex, because SbF5 is a Lewis acid and it will immediately get fluorinated whenever there is any fluoride providing groups are coming. So you'll get this as MnF4. It will become MnF4. And MnF4, what you get on heating, will convert this into MnF2 plus F2. Got it? So now if I write the overall reaction of it, so basically what you are getting is K2MnF6 plus 2 moles of SbS5, right? That will convert into 2 moles of potassium SbF6 plus MnF2 plus F2. So that's how we will get fluorine out of. Yeah. I hope this point is clear. These are the preparation reactions, guys, which you need to know. Okay. And as much as the preparation is concerned, as much as the chemical reaction is concerned, this is how much we need to learn. Now, one thing which is remaining in this case is about how the bleaching powder acts. Let us see. bleaching powder. Got it? Now what you do, we take calcium hydroxide and treat that with Cl2. That will form CaCl2 plus CaOCl twice. Okay. Now, if I keep this as a, at a lower temperature, it will all appear like a powdered form, and that will be CaCl2 dot CaOH twice dot CaOCl twice dot 2H2O, and this is what we call it as bleaching powder. Bleaching powder. Okay. So usually this one, or you can expect that it is a mixed salt of CaOCl2, which is basically Ca2 plus OCl minus and Cl minus. This is how ionically bonded. This is how it is ionically bonded. Okay. Which means out of this entire bleach, the only reactive part is this one. Correct. And that also will exist in the form of CaOCl2. And whenever the bleaching action, the bleaching powder's reactions are seen, that means you are worried about this one. So what are the reactions it goes through? See that CaOCl2, right? If you keep it for long standing, it will convert into CaCl2 plus half O2. This is the reaction that happens. Next, if you react CoCl2 change into Ca2 plus Cl minus plus OCl minus. Now Cl minus plus OCl minus plus H2SO4, you notice, that will give us HCl plus HOCl plus SO4 2 minus. And this HCl plus HOCl will form Cl2 plus H2O. Cl2 plus H2O. Now, if I write the overall reaction for this, what do I get? So basically, CaOCl2 plus H2SO4, right? Or I can take CH3COOH also. That means any mild acids will convert into either calcium sulfate or calcium acetate here, plus Cl2 plus H2O. Basically, this is helping us to understand how much amount of chlorine is present in it. This is called percentage available chlorine in bleaching powder. So how much amount of percentage is available in the bleaching powder? Okay. So in short, for identifying the bleaching powder, this is the method we use. Suppose if you have a W grams of bleaching powder, first we react that with acetic acid. On reacting with acetic acid, we'll get an calcium acetate salt, okay, plus Cl2 plus H2. Okay. And if you notice, iodometry, Cl2 plus I minus, okay, will give you I2 plus 2Cl minus. Got it? And whatever the I2 which you have got, okay, we will react with thiosulfate. And from that thiosulfate, you will know that we'll get 2NaI and Na2S4O6. Okay. So if you recall, whatever the chlorine that has been released, we react with some excess Ki, convert that into I2. And whatever I2 that we get, we do the titration with sodium thiosulfate. Based on this, we know that how much amount of molarity and what is the volume that we have used. I can say number of moles of Na2S2O3 which are used is equal to M into V. Okay. And number of moles of I2 that are consumed will be M into V by 2, because if you take the mole ratio, it is 1 is to 2. For every 1 mole, we require 2 moles. So whatever moles we have divided by 2 will be the number of moles of iodine. So which is also same as the number of moles of chlorine from the above reaction here. Correct. Now we know the number of moles. We can note what is the weight of chlorine. Weight of chlorine will be equal to M into V by 2 into 71. That is the weight of chlorine. Okay. So how much is the percentage available chlorine now? Percentage available chlorine in bleach. Chlorine in bleach will be equal to MV into 71 by MV into 71 by 2 into W grams into 100. So this is the percentage available chlorine in the bleach. Guys, understood? This is the reaction we need to know, and how to find out the percentage available chlorine. So it's very easy. Question will be asked this way, giving the weight of the bleaching powder, and from there you directly use this formula to figure out how much amount of percentage available chlorine is. Okay. Bleaching powder uses are many. Okay. Reactions of CaOCl2. In fact, basically we are talking about OCl minus. If you have CH3, CH2OH, an alcohol, that is ethanol, and if you use OCl minus, we know that it is a haloform reaction. So we'll get CHCl3 plus HCOO twice calcium. This is the product form. Okay. The product can also be formed even if you have this kind of alcohol, OCl minus. Here also we'll get CHCl3 plus CH3 CO twice Cl. Okay. Now by chance, if you make a dry distillation for this, we end up getting ketones again. C double bond O, CH3 plus CaCO3. Okay. In fact, industrially, haloform is prepared this way. Okay. What are the other reactions? Because it will act like a good oxidizing agent. COCl2 acts as good oxidizing agent. So now you notice that if you have CaOCl2 and then treat with these various compounds, starting with H2S, so it will become colloidal sulfur. Next, FeSO4, it will become Fe plus 3. If we treat with NO2 minus, it will become NO3 minus. If you have ASO3 3 minus, then you will have ASO4 3 minus. And if you have SO3 2 minus, it will become SO4 2 minus. Next, if it is I minus, it will become I2. And lastly, if you have NH3, you get N2. Okay. These are few reactions which you will notice from bleaching powder. Clear on this point, everybody? Right. So as much as the topic is concerned, okay, this much is what is there in your